So let's continue with solving these equations. So solve for all solutions. So we'll start off with the first one, and here's where you want to tap into all your possible algebra skills that you have learned so far in the past. So here we can kind of see like a mix of kind of like a polynomial where you can FOIL it out. FOILing it out actually is the worst thing that you can do. So here we can actually just break them apart and just say tangent squared theta minus 4 equals 0. And 2 cosine theta plus 1 equals 0. So here, let's just add the 4 over. So you're going to get tangent squared theta is equal to 4. And then we're going to take the square root to both sides and add a plus or minus. So you're going to get tangent of theta is equal to plus or minus 2. Okay, so now let's go ahead and figure this out, because notice that tangent of 2, tangent of theta of 2, that's not on the unit circle, which means that you're going to have to use an inverse function. So first, let's go ahead and figure out what arctangent of 2 is. So in this case, we're going to take arctangent of 2. That's going to give me 1.1, yeah, about 1.1. So 1.1 plus pi k. Okay, so that's the first one. Now remember that tangent is positive in the first quadrant. Okay, so let's say this is 1.1. So this is the angle 1.1. Remember that tangent is also positive on the other side. Okay, which is going to be this guy right here. So adding pi will give you the other angle. So the other angle would be theta is equal to whatever 1.1 plus pi is. So 1.1 plus pi. That's going to give me 4.24. And that's just going to give me plus pi k. Now again, this is kind of redundant, so you could have just left it as theta equals 1.1 plus pi k. If I have said find each individual, then it will just be 1.1 and 4.24. Okay, so now let's do the other one. So because we also got to do the negative side. So we're going to go ahead and do inverse tangent again of negative 2. That's going to give me negative 1.107. Okay, so and then I'm just going to add plus pi k clearly for that one. Now this negative sign is going to be down here, because remember tangent inverse has a restriction of negative pi over 2 to pi over 2. So negative 1.107 is down here. So the distance from here to here is going to be 1.107. So the other one is going to be on the other side, which is just basically adding pi over. So theta is going to be equal to whatever that is plus pi. That's going to give me 2.03 plus pi k. Again, this is a little redundant. You could have just written theta equals negative 1.107 plus pi k and be done with it, because it's just every pi unit. So, but that's basically all it is. Now this next one, this one's a little bit more straightforward. Subtract the 1 over. So you get 2 cosine of theta equals negative 1. Divide by 2, you're going to get negative 1/2. So now negative 1/2 is in the unit circle. So when I go into the unit circle, negative 1/2 for cosine is going to be right here and right here. So that's at 2 pi over 3 and at 4 pi over 3. So theta is going to be at 2 pi over 3 plus 2 pi k, and then 4 pi over 3 plus 2 pi k. And for all of these solutions, k is an integer. Okay, so usually dealing with the 2 pi case is usually really easy. There's not a lot to it. Okay, so now let's do part B. So let's say you wanted to do 3 sine squared theta minus 7 sine theta plus 2 is equal to 0. Okay, so now this one looks a lot like a quadratic. So in this case, you can try to factor it if you can, because this looks a lot like 7x squared. Oh, sorry, that's wrong. This looks a lot like 3x squared minus 7x plus 2 equals 0. And the way that we usually solve for these, especially if your factoring skills aren't that great, you can always just use a quadratic formula. Now, when you use a quadratic formula, we're using it for x. Now, in this case, we're using it for sine. So that tells me that sine theta equals negative b plus or minus square root b squared minus 4ac all over 2a. Because in this case, we don't have x, we have a sine theta. So all we got to do is just plug in the b. So b is going to be negative 7 plus or minus square root b squared. Okay, so b is going to be negative 7 squared minus 4ac all over 2a, which is going to be 3. Okay. So then what we have is sine theta is equal to positive 7 plus or minus square root of 49. And then this is going to be 12 times 2, which gives me 24 divided by 6. So 49 minus 24 is going to give me 25. So that gives me 7 plus or minus square root of 25 divided by 6. So you're going to end up with 7 plus or minus 5 divided by 6. Okay, so you get 7 plus 5 over 6, and then 7 minus 5 over 6. So now, what is that going to give me? So 7 plus 5 is going to give me 12 divided by 6 is going to give me 2. And then 7 minus 5 is going to give me 2 divided by 6 is going to give me basically 1/3. So what that tells me is that sine of theta is 2 answers. It's just, it's 2, and sine of theta is equal to 1/3. Okay. So for the first problem, is it possible that you get sine of theta 2? Well, no, right? Because one thing you can do is you can go into your calculator and see what the sine inverse of 2 is. You can see that does not exist. So this one, there's no solution for this guy. And that kind of makes sense because if you were to draw the sine curve only has a range between -1 and 1. It cannot go past 2. All right, now here we have another weird one because sine of theta equals 1/3 is not in the calculator. I'm sorry, it's not in the unit circle. So we have to use the calculator in this case. So the first thing that we're going to do is take sine inverse to figure out where exactly 1/3 is going to be. Okay, so we're going to take the inverse sine of 1/3. That's going to give me about approximately 0.34, okay, plus 2 pi k. We want all solutions. That's the first one. Now, where's my other one? Well, what we got to do is that, well, 0.34 is going to be in the first quadrant because, you know, the sign is restricted between -pi/2 and pi/2. The next one, well, all students take calculus, is going to be here. That's the other guy. So if this is 0.34, this guy should also be 0.34 by symmetry. Okay, so how do I do that? So remember, if I want to figure out what this angle is, well, I know that the entire thing is going to be pi units. So I'm going to take pi minus 0.34, and that's going to give me this other angle. Okay, so I'm going to take pi minus 0.34. That's going to give me 2.8 plus 2 pi k. So that's going to be my other solution. So basically, the only solutions are this guy and then this guy. Okay? All right, so now let's do a couple more. So now we're going to do some that require a couple of identities. So for example, sine 2 theta plus cosine theta equals 0. And let's just do it from 0 to 2 pi. Okay? So here, we don't want to deal with sine 2 theta. We don't like dealing with multiple sine and cosine functions. So instead, what we're going to do, we're going to take sine 2 theta and use a double angle identity. So this is just going to be equal to 2 sine theta cosine theta. Okay, but this is by using the double angle identity. Okay. Notice here we can factor out a cosine. So I'm going to be left with 2 sine theta plus 1 equals 0. Okay, now that we've factored that out, I can just break them up. So I got cosine of theta equals 0, and 2 sine theta plus 1 is equal to 0. Okay, so here you can see that we're looking for all the values of cosine where you get 0. So let's go back to the unit circle. So where is cosine equal to 0? Okay, so cosine is equal to 0 right here. So at pi over 2 and also at 3 pi over 2. Okay, so at pi over 2 and at 3 pi over 2. So these are my two solutions for that guy since we only want 0 to 2 pi. This guy is going to be sine of theta equals -1/2 because I can subtract the 1 and divide it by 2. So where is sine of theta equal to negative 1/2? Okay, so that one, so negative 1/2, let's see. Here, 7 pi over 6, and here, 11 pi over 6. So it's going to be 7 pi over 6 and 11 pi over 6. That's going to be my answer. So sometimes you do have to plug in a couple of identities to make it a little bit nicer. Usually the double angle identity, and sometimes even like the Pythagorean identities. So if you remember the Pythagorean identities, they're just cosine squared theta plus sine squared theta equals 1. Sometimes you can always write cosine squared theta equals 1 minus sine squared theta. And also sine squared theta equals 1 minus cosine squared theta. So you can always write it like this as well, just moving the cosine or the sine over. So sometimes that can work. Okay, so now let's do one last one. So let's say we wanted to solve this guy. 3 tangent cubed theta minus 3 tangent squared theta minus tangent of theta plus 1 equals 0. Okay, so in this case, what we want to be able to do is, well, this kind of reminds me of the polynomial. Remember when you had 4 different terms and then you had a cubed? Then remember what you can do is you can just factor by grouping. Okay, so I'm going to group these guys. So I can take out a 3, and I can also take out a tangent squared. Okay, and what I'm left with is just a tangent of theta minus 1. Okay, and then in this guy, I can just take out a negative 1, and I'm left with a tangent of theta minus 1. So I'm basically factoring by grouping. So now what you can do is notice that these two guys have a tangent of theta minus 1 in common. So you're going to take out that tangent of theta minus 1, so this guy goes away. So all I'm left with is what's ever left over. So 3 tangent of theta, a tangent squared theta, and then this minus 1 is equal to 0. And now I can just solve for this. So you get tangent of theta equals, tangent of theta minus 1 equals 0. And then 3 tangent squared theta minus 1 equals 0. Okay, so here I get tangent of theta is equal to 1. So now I'm looking for all the values of tangent where theta is equal to 1. So let's go to the unit circle. And we get that it's equal to 1 here. Okay, so here's 1, and here's another 1. So at pi over 4 and 5 pi over 4. Pi over 4 and 5 pi over 4. Okay, and now this one, so let me add 1. So you get 3 tangent squared of theta equals 1 divided by 3. You get tangent squared theta is equal to 1 over 3. Take the square root to both sides with a plus or minus. It's going to give me tangent of theta is equal to plus or minus, and I rationalize that. That's going to be square root of 3 over 3. Okay, so now where is theta going to be equal to plus or minus square root of 3 over 3? Okay, so let me go back. Whoops. So square root of 3 over 3 is right here, and we want all of them, all positive and negative. Whoops. So that one's going to be at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So 1, 5, 7, 11. So 5 pi over 6, 7 pi over 6, and 11 pi over 6. So all of these guys are going to be solutions to this particular problem. Okay, so yes, you do have to remind yourself of all these factoring by grouping stuff, the quadratic formula. If your factoring is kind of off, clearly you can't use quadratic formula here, so you have to do some sort of factoring by grouping. So these are just basically some of the equations. Obviously, there's a many different ways that you can do them. I'm not going to do a whole bunch of problems anymore, but if you do still need a little bit more help, just let me know.